Critical velocity of a fluid. So you see, when a liquid flows through any pipe, the flow of the liquid can be streamlined, can be turbulent, or can be laminar. So there is a velocity of the liquid. Below a value of that, the velocity, the flow of the fluid will be streamlined, and above that limiting value, the flow would be more irregular and more turbulent. So this velocity is called the critical velocity. So we can define it like this, that the velocity of a liquid up to which the flow of the liquid is streamlined, and as the speed increases even more further, then the velocity, the flow of the liquid become more turbulent. So this critical velocity is called critical velocity. Critical velocity of a fluid depends on the density of the fluid, the diameter of the pipe through which it is flowing, and the coefficient of viscosity of the fluid. We can derive an expression for this value of V using dimensional analysis very easily. As you can see, V, we can denote the critical velocity by the letter Vc. So Vc will be definitely, you can see, proportional to the coefficient of viscosity eta to the power A, then density of the fluid rho to the power B, and diameter of the pipe, which is d to the power C. So as you know, whenever we remove the proportional sign, we should get a constant. This constant K is called Reynolds number. We will see to that. Then rho B, then dc. Then the dimension of velocity, as we know, it is L t to the power minus 1, and here K. The dimension of eta is M L inverse, L to the power minus 1, t to the power minus 1 to the power A, and density is M L to the power minus 3 to the power B, and then definitely diameter is simply L to the power C. Now we can bring all the base quantity, fundamental quantities, power all together. So we can get here K M to the power A, then A plus B, then L, I should get here minus A, and then minus 3B, and then minus 3B, and then plus C, and finally T should give me minus A, T to the power minus A. So this side is L T to the power minus 1. We can compare the terms of the terms of the fundamental quantities left hand side and right hand side. We can see that A plus B is equal to 0, and then minus A minus 3B plus C is equal to 1, and minus A is equal to minus 1. So this one clearly implies that A is equal to 1. So if A is 1, then we can put it there. B will also give me here, B will become so B is going to clearly become minus 1. B is going to be minus 1, A is 1, and finally if we put it here, A is equal to minus 1 and B is minus 3 minus 1 plus C equal to 1. This gives me minus 1 plus 3 plus C equal to 1. So I can see from here, this is 2, C is going to give me, C is going to be minus 1, 3, 2, minus 1 here. C is going to be minus 1. So we'll substitute these values in this main equation, and it should help us to get the value of critical velocity. So if I use it, so we should get here Vc is equal to K eta to the power A. Eta is A is to be, A is 1, so eta into then density to the power B is minus 1, density power minus 1, and diameter d to the power minus 1, t to the power minus 1. So implies the critical velocity should be equal to K eta by rho d. This is critical velocity of the fluid. So you can clearly see the critical velocity depends on the coefficient of viscosity eta, density and diameter. With the density is inversely proportional, with the diameter it is inversely proportional. It means if the diameter is more, diameter is large, here the critical velocity will be less, and if the diameter is small, critical velocity will become more. Accordingly, it depends there because they are inversely proportional. On the other hand, Vc is directly proportional to eta. So if eta is more, critical velocity will be of the fluid will also be more. And this constant that we see, this k, the constant k is called Reynolds number. The constant k is known as Reynolds number. Where do we heard about Reynolds number? Reynolds is a person who has one of the first person to develop the ballpoint pen. So that's why on his name he has worked on this field a lot and developed the first ballpoint pen, which is made of nothing but a fluid along with a small spherical ball here. The liquid flows through there in a streamlined flow, and then as it flows over the paper, it writes it. So it's the Reynolds who was the first person to do it. He was a pen salesman selling pen. So he always used to have complaint regarding that this fountain pen also always used to spill and also on. So later he developed this pen. So R is the Reynolds number. So clearly you can readjusting this equation, you can see the Reynolds number can be written as rho v d by eta. The value of Reynolds number, the importance of Reynolds number is that if R lies between 0 and 2000, the liquid flow is streamlined. The liquid flow is streamlined. It is a streamlined flow. And if the R is greater than 3000, the flow of liquid is turbulent. Flow of liquid is turbulent. Is turbulent in that case. Okay, and if R is in between 2000 to 3000, the flow is more unstable. So if R is between 2000, means it is greater than 2000, and less than R is greater than 2000 but less than 3000, the fluid flow is unstable fluid flow, unstable flow of fluid. So that's it. So these is one of the most important criteria that determines how the flow of the fluid through a pipe will be. Thank you.